In today's practice problems, we are going to be looking at solving equations that deal with scientific notation. So looking back at what scientific notation was, this was in Unit 3, and we had just learned about exponent rules, and we started looking at these numbers. So we take a number from standard form, and if we want to make it a more condensed form of the number, a little bit cleaner, what we had to do was we take the decimal place and we move it over until we get something that's between 1 and 10. So the decimal place went right here in this example, between the 2 and the 5. And because we moved the decimal 6 places to the left, it has an exponent of 6. So 2.54 times 10 to the 6th is that number in scientific. We could also take really small numbers and do the same thing. So if we want to have a condensed version of this number, we take its decimal point, and we're just going to move it until we have a number that's between 1 and 10. So this decimal place is going between the 8 and the 2. And because we had to move it 1, 2, 3 places to the right, we have an exponent of -3 because we had to move right. So we had to remember all these little things, like down here. If we move the decimal left, our exponent becomes larger. If we move it right, our exponent is reduced. So all these little things we're going to have to remember when we solve these equations. Let's see what else we had in this unit. This is just an example of step-by-step moving something from standard into scientific. So if you need to pause it here and read through that, that might be helpful. And this one is going from scientific to standard, just if you needed a reminder. And then, that's when you guys had to play war and compare numbers. This one we are going to have to look at today. Where's my adding and subtracting one? You might want that. So we are going to have to add and subtract and then multiply or divide numbers in scientific notation today. Bless you. Clayt? You don't. All right, so let's finish looking at this. Here's our adding and subtracting. We're going to be doing this today too. So when you add and subtract numbers in scientific notation, your exponents on your tens have to be the same. But I'll show you that when we get to it. All right, enough looking back at notes. Let's get started. Here are the problems that I have for us today. And this is what you guys will be expected to be able to do also. In my first one, I have x plus something equals a number. So any other equation, you guys would know what to do here. This is just a one-step equation. This is just a number. So if I want to get rid of it, I need to move it to the other side of the equation. So let's say I wanted to take this and move it over as a one-step. Right now it's being added, so I'm going to subtract it from both sides. Remember, this is just a number. It's just a simplified form of the number. We're going to do the same thing on this side. Cancels off here. And we have x equals, now on this side, when we're subtracting numbers in scientific notation, think of this as having 6 of something, and we're taking away 4 of those things. So if you have 6 of something, you're taking 4 of them away. We're left with 2 of those things. The reason we are able to do this is because both of these are 10 to the third power. So they're like terms, so I can put them together. So my answer is that x equals 2 times 10 to the third. That's my answer. So my problem started with scientific notation. I have a number between 1 and 10 times 10 to a power. And it ended in scientific notation where I have a number times 10 to a power. So let's look at the next one. I have x minus some number equals another number. So it's a one-step problem. And I need to move this to the other side. So if I want to take this and move it over there, we need to do the opposite of what's happening. So right now it's being subtracted. So I'm going to do the opposite. I'm going to add it to both sides. Okay, so it's going to cancel off of this side. X is by itself. And then making sure we have like terms. We've got 3.5 of something plus 2.5 of those same things, right? So we have like terms. So I can put them together. 3.5 plus 2.5 is going to give me 6 of those things. So that's my answer. My answer's in scientific notation. I've got a number between 1 and 10 times 10 to a power. All right, the next one, I made it a little bit more difficult. So let's go ahead and take a step. We have 3 times 10 to the second, and I have 5 times 10 to the third. Right now, those are not like terms. So what I need to do is I need to either get this to be a 10 to the third or make this into a 10 to the second. It doesn't matter which one you do. This is where we use the left is larger, right reduce. I think what I'm going to do is make this into a 3. So if I'm going to make my exponent larger, I need to move my decimal to the left. So this is going to become 0.3 times 10 to the third. Now I'm going to have like terms. So I have 10 to the third and 10 to the third. So now I can do my next step. I want to get rid of this number, so I'm going to add it to both sides. They cancel off of here. I have x alone. And now I can add because these are like terms. So 5 of something plus 0.3 of those things is 5.3. My numbers in scientific notation at the end. This is between 1 and 10, and it's times 10 to a power. All right, our last one. It looks hard, but it's actually one of the easiest ones. So we have x divided by something equals another number. If you're already lost, I want you to stop here and just ignore this. If you're not lost, keep going. So when x is being divided by something, the way we get rid of it is we multiply both sides by that number. So they cancel off. X is by itself. Now, the rules are a little bit different here. Now we're multiplying two things. So when we multiply these, we're going to multiply their coefficients. And then we add the exponents on the tens. So 7 plus 4 is 11. My answer is in scientific notation. This is between 1 and 10. And I have times 10 to a power. So that one's a little bit different because we have multiplication involved. So if you were just getting your addition and subtraction, I want you to focus on these first. If those are making sense, then you can jump down and give this one a try. All right, good luck.